So in this section, we're going to look at isosceles triangles. So we're first going to look at just what the sides and the bases are and the base angles. So the side of the isosceles triangles, there's two sides. So those sides are AB and AC. The base is the very bottom, so that is side BC. And then the base angles are on the base. So we've got angle B and angle C are both base angles. Now in this chapter we have a few theorems. So the first theorem is the isosceles triangle theorem. So that says that if the sides of an isosceles triangle are congruent, then the base angles are also going to be congruent. The converse is the flipped version. So that says if the base angles are congruent, then the sides are going to be congruent. And then our last theorem with isosceles triangles is if you have an angled bisector in an isosceles triangle where the two sides are congruent, then you're going to get a perpendicular bisector. So that's going to look like you have a right angle and then your base is going to be bisected, so cut in half. So then those two bottom sides are going to be congruent. So the corollary to theorem 4.3 is with equilateral triangles. So same concept, we have all three sides are congruent in an equilateral triangle. So that means that all three angles are going to be congruent in an equilateral triangle. Then we also have the converse of the corollary. So that is that if all of the angles in an equilateral triangle are congruent, then all of the sides are going to be congruent. And then this question down here says how many degrees are the angles in an equilateral triangle? Well, we know that in a triangle there's 180 degrees. So if all the three angles are congruent, we divide it by 3. So in an equilateral triangle, all the angles are going to be 60 degrees. So now we're going to look at some example problems. So our first example problem says to find the values of x and y. So if we look here, we have that the two sides are congruent. So if the two sides are congruent in isosceles triangles, we know that angle x is going to be congruent to angle y. So we have to use what we know about triangles and their sum of angles. So the sum is 180 degrees. Well, we already have 50 of it, so we're going to subtract the 50 degrees to see how many degrees we have left, and that's 130 degrees. And then if we know that the x and y are congruent, we can just divide the 130 by 2. So then we know that x is going to equal y, and they're both going to equal 65 degrees. And you can check your answer by plugging that into the triangle. 65 plus 65 plus 50 should give you the 180. Now problem 2 goes with our perpendicular bisector theorem. So what we have here is we have, this is a bisector, so we're going to get a right angle, and we're also going to get that these two sides are congruent. So if we look, y is going to be the same as 8, so that one's nice and easy. To find the angle, there's a few different ways we can go about it. We know that we have this triangle here, we've got 90 and 58, and we got to figure out what x is. Well, 180 minus 90 is just 90, so then we have 90 degrees minus 58, and so that is going to give us 32 degrees for x. You could have gone the long way about finding x, and you could have made this angle 58, and then found out that the other angle up top was 64, and then divided it by 2 to get 32. That is an option as well. Or you could just do 90 minus 58. It depends how you see the connection with the problem. And then our last problem here, we have the two base angles are congruent, so we know that the two sides are going to have to be congruent. So this side has to be congruent with this side. So if the one side is 12, then x has to equal 12. Then we know that the base angles are congruent because they have the arc marks. So if this is 48, this angle is also 48. And then we're going to just subtract from 180. So we're going to take 180 minus 48 and minus another 48. You could also add them first and subtract. So then you get angle y is going to be 84 degrees.